An application architect is a senior technical professional responsible for designing the structure and components of software applications. They play a crucial role in ensuring that the application meets both the technical and business requirements, while being scalable, secure, and efficient. They bridge the gap between business stakeholders, developers, and other IT professionals to build and implement effective software solutions. Below is a detailed explanation of their roles, responsibilities, and involvement in the application development process, with examples. 1. Roles and responsibilities. 1.1 Architectural design and planning. An application architect is responsible for designing the overall architecture of the application. This includes selecting technologies, frameworks, and platforms that align with business needs and technical requirements. Example, if an organization needs to build an e-commerce platform, the application architect decides the architecture style, for example, microservices or monolithic, the technology stack, for example, Node.js for the backend, Angular for the frontend, and integration with third-party services, for example, payment gateways, shipping APIs. 1.2 Requirement analysis. They work closely with business analysts, product owners, and stakeholders to understand the business requirements, translating them into technical specifications. Example, if a healthcare provider wants to build a patient management system, the application architect will analyze requirements like appointment scheduling, patient data security, HIPAA compliance, and integration with electronic health record, systems. 1.3 Technical leadership and guidance. They guide development teams in implementing the architecture, coding standards, and best practices. They also mentor junior developers and provide technical leadership throughout the development lifecycle. Example, during the development of a financial application, the architect may review code to ensure adherence to secure coding practices, for example, OWASP standards, helping developers avoid vulnerabilities like SQL injection or cross-site scripting. 1.4 Scalability and performance optimization. An application architect ensures that the application can handle increased load and scale as the business grows. They design systems that are resilient, scalable, and perform well under varying conditions. Example, for a streaming service like Netflix, an architect would design a system using cloud services like AWS or Azure, and implement load balancers and caching mechanisms to handle millions of concurrent users. 1.5 Security and compliance. They are responsible for designing secure applications that comply with regulatory requirements. This involves implementing security best practices and ensuring compliance with standards like GDPR, CSS, or HIPAA. Example, in an e-commerce application, the architect will design secure payment processing and user authentication mechanisms, using encryption and tokenization to protect sensitive customer data. 1.6 Integration and interoperability. An application architect designs systems that integrate seamlessly with other services, APIs, and third-party solutions. They ensure interoperability between different systems, often through APIs, middleware, or service-oriented architectures, SOA. Example, when developing a customer relationship management (CRM) system, the architect might design integration points with marketing platforms, email services, and sales databases to streamline information flow and automate processes. 1.7 Documentation and communication. They create detailed technical documentation, including architecture blueprints, flow diagrams, and API specifications, and communicate these to developers and stakeholders. Example, for a banking application, an architect might provide a detailed architecture diagram showing how the application's microservices interact with databases, third-party services, and user interfaces. 1.8 Technology evaluation and selection. Application architects stay up to date with new technologies, tools, and frameworks. They evaluate and select the most suitable ones for a given project, considering factors like performance, security, cost, and team expertise. Example, an architect may decide between using a traditional relational database like MySQL versus a NoSQL database like MongoDB based on the need for flexibility and scalability in a social media application. 1.9 Monitoring and troubleshooting. They are involved in setting up monitoring systems to track application performance, detect issues, and troubleshoot problems. They may use tools like application performance monitoring, APM, systems, for example, New Relic, Datadog, to keep the application running smoothly. Example, in a logistics application, the architect may configure monitoring tools to alert the team if API response times exceed a certain threshold, indicating performance issues that need resolution. 2. Important aspects of the application development process. An application architect is involved in several key phases of the application development lifecycle. 2.1 Planning and feasibility analysis. The architect assesses the feasibility of the application based on technical, budgetary, and time constraints, and develops a roadmap for implementation. 2.2 Design phase. This is where the architect's primary role comes into play. They design the application architecture, defining components like Front-end architecture, for example, React, Angular frameworks. Backend services, for example, microservices architecture using REST APIs or GraphQL. Database design, choosing between SQL or NoSQL based on requirements. Integration mechanisms, for example, APIs, message queues like RabbitMQ. 2.3 Development and implementation. They collaborate with developers, offering guidance and ensuring that the implementation aligns with the designed architecture. They may review code and help resolve technical issues. 2.4 Testing and quality assurance. Architects work with CAD teams to design test strategies, such as automated testing frameworks or performance testing tools. They ensure that the application's architecture supports efficient testing and bug fixing. 2.5 Deployment. They define deployment strategies, which may involve C/CD, continuous integration / continuous deployment, pipelines, containerization, for example, Docker, and cloud platforms, for example, Azure. 2.6 Maintenance and updates. The architect ensures that the application is maintainable and scalable. They plan for future updates, performance optimizations, and scaling strategies. 2.7 Retirement and migration. When applications become outdated, the architect designs strategies for decommissioning or migrating to new systems with minimal disruption. Examples of application architect contributions. E-commerce platform. An architect designs a microservices architecture that separates different functionalities such as product management, order processing, and payment services, allowing independent scaling and easier updates. Healthcare application ensures that the application is HIPAA compliant by implementing secure data storage, encrypted communication channels, and multi-factor authentication for users. Banking software designs a resilient and secure architecture using event-driven microservices, ensuring high availability and fault tolerance for critical financial transactions. In summary, an application architect is a strategic role responsible for the technical vision and execution of software solutions. They are involved in every aspect of application development, from planning and design to deployment and maintenance, ensuring that applications are robust, scalable, secure, and align with business goals.